All right, welcome to Lecture 13 of Stanford CS193p, spring of 2025. This week is all about SwiftData, which is making our data persistent when our app is quit or killed, or our phone turns off and back on, and we come back and we want all of our information to be there. And SwiftData is the mechanism we use for that. And the data that we're going to be storing is actually all stored in a SQL database, but we don't really know that that's what's going on. We don't need to know. We interact with SwiftData much more at the Swift level, where we're using normal structures and closures and things like that. So the way this is going to work is I'm going to give you some quick slides. I'll try to get through them as quickly as possible so I don't run over on time over on the demo. And then the demo is going to have two parts. Part one today is we're going to take our model and convert it into a persistable SwiftData-like model. And then on Wednesday, we're going to use the fact that we have a persistent model to do things like make our games be stored, but also search them, sort them, stuff like that, all using database operations, right? SQL sorting, SQL searching, all that stuff. So that's the way this will play out. All right. What do we need to do to take our model? We have this nice code breaker, plays the code breaker game. How do we make it persistent? How do we make it work with SwiftData? Well, the first thing we're always going to do is we're going to have the big or important or main parts of our model be marked with @model. @model essentially says this class, this part of my model, needs to be made persistent. And it's a macro, just like @observable is a macro. And it only works on classes, so you can only put classes in the database. And you might have structs in your model currently, like we do, that we're going to have to convert to a class if we want to put them in there, and that's perfectly fine. We'll get a reminder what we need to do that. And if you put @model on something, it's going to be automatically @observable. So you never would put both @model and @observable. It makes no sense, and @model is observable. Now, when you put that @model onto one of your things in your model, all its vars now are going to be restricted a little bit. And you can kind of imagine why this is, right? You're going to take this thing in your model and put it in a SQL database. Well, SQL is limited in what can be stored in there, and so we're going to have to kind of constrict our vars to fit into certain parameters so that we can SQLize it essentially underneath. So let's talk about the types of things that our vars can be if we have an @model. Obviously, they can be all the primitive types. So that's numbers, strings, booleans, dates, and also this thing data, which I haven't even talked about data, but data is essentially like a bag of bits, like a buffer of bits. So really a lot of things can be converted to and from a data and stored in the database. But primitive types obviously can be put into the database. Another interesting one, of course, is other @models. So your var could be something that is itself a model. Now remember, each @model is kind of going to end up being a table in a database. Right? How many people here have taken some database program? You know a little bit about how databases work? Maybe half, a little more than half. So, each of these @models is going to end up in its own table. And of course, we might want to have relationships between the tables, right? Things in one table pointing to other things. And so if your var in your @model is itself an @model, then you've created a relationship. And we're going to talk about how we manage those relationships in a moment here. Another kind of big way to take some struct or something you have that you don't want to make it its own @model so that it has its own table, but you want to put it in there, is that you can make a struct or an enum that you have conform to a protocol called Codable. And Codable is really just a protocol that lets you take all the parts of your struct or enum and put it in a little bag so it can be put into the database and then pulled out of the database, and then the bag's opened back up and your thing exists again. It's great in that you can put pretty much anything in there because you can make anything codable, but it's also a little bit limited because when it's in the database, it's just a little blob, right? So you can't really search on it very much. You could search for equality, but you can't look at the component parts of it. So it's got pluses and minuses to using Codable to throw things in the database. And then, of course, you can have optionals of any of these things. Optionals are perfectly allowed. And they can be arrays of any of the above, but with a huge warning that arrays of @models will be unordered. And you can see why this would be actually, right? If you have an array of at-sign models, you're actually kind of joining into another table, right? Those at-sign models are kept in a different table in the database, so you're kind of doing an implicit query into that other table to get that array of things back. And when you do queries into the database, they come back unsorted unless you specify a sorting mechanism. So it's up to us when we have an array in an at-sign model to ensure it's in the proper order. And it really matters to us. For example, in our game, we want the attempts in order. We don't want it to, every time it saves it, come back with a different order of attempts. No way. That matters to us, and so we're going to have to manage the order of our attempts, for example. So what if you have a var in your at-sign model and it's not one of these things above here? Well, there's some strategies to deal with that. Real good one is create a computed var that converts it to one of the things above, especially the primitive types. It's really nice to convert fairly simple structs and enums into a string or some other primitive type. And then you have this computed var so that the rest of your code still thinks it's the old type, because the computed var will be of the original type, and then your actual var in your at-sign model will be probably an underbar version of it that's one of the primitive types. And I'll show you that in the demo. And we can also use this computed var strategy for arrays, right? We want our arrays to be ordered. Well, what if we make just a little computed var that when you get the value, right, the get part of the computed var sorts it in the right order, depending on what that means for us. And then the set can just set it. So computed vars can be a good way to put a little wrapper around the fact that we can't always have exactly the types we want in our at-sign model. Now, of course, we could take any existing type that we have that doesn't qualify above and make it an at-sign model or make it a codable. Okay, that is always an option. Making something an at-sign model creates a whole other table for it in the database. You probably wouldn't want to do that with simple little things, but it's not that high overhead to do it, so it's not really that big a deal. And then a codable, of course, easy to do, but kind of opaque in the database. And there is an advanced way to do it. I'm really not even going to talk about it. There's this protocol of value transformer, and you can put a little attribute notification on your var that actually transforms it from one type to another. So there is an official way to do it, but we rarely do it because these other ways are all such good ways to get our at-sign model vars into the database. Now, speaking of this at-sign attribute thing, what is that? Well, all your vars in your at-sign model can be marked with one of these little things right here. Just goes right before the var. If you have var name something, you can put at-sign attribute in front of it or whatever. These are called schema attributes. A schema, everyone know what the word schema means? That's basically just describing the data structure of your database. That's its schema. And so these are attributes of the schema. And I'll just go through these quickly. We don't use them that much, but like the first one, at-sign attribute unique, that just means that this var in this at-sign model can only have a certain value for one entry in there. So like if you're doing an employee database, this might be the employee's ID, not his first name or his last name. That's not unique, okay? But the ID of the employee probably is unique. So you would mark it @var unique. We don't have any of those in our code breaker. We don't have any uniqueness for any of our vars. External storage, that's if you're going to put big things like video or even like a JPEG image or something like that. If you mark it @attribute external storage, then it'll store it somewhere in the file system and then just put a reference in the database. Okay, we don't want to fill our huge SQL databases with gigantic pieces of data. And then transformable by, we saw that. Ephemeral and transient, those are for vars that you want to have in your at-sign model, but you never want them to go to the database. Right? So they're just things that are only used like while your program is running. You don't need to store them. And we'll have an example of that in CodeBreaker. And then a relationship down there, this is what I was talking about before. If you have a var in an at-sign model and the type of that var is some other kinds of at-sign model, well, you've implicitly created a relationship between those two tables. And you can control things in the relationship. For example, the delete rule says, if I delete, for example, my code breaker, does it go over to the codes table and delete the master code and the guess and the attempts? Which obviously it should. So we will be putting @sign relationship delete rule cascade, that's what that delete rule is. It cascades into the other table. And there's also this inverse thing, which is if you had a back pointer, let's say our codes in our code breaker had a back pointer to the game they were in, well, then you could put a little @sign relationship inverse and specify which var is the back pointer. And that way, SwiftData would know both sides. And that way, it also can know whether it's a too-many relationship, like if it's the back pointer is to an array, or whether it's a one-to-one relationship. Both sides are not that. you go to all this trouble to create your @sign model, and you make all your vars be the primitive types or @sign models or whatever to make it all work, and maybe you put some schema attributes on there. Now you want to store your models in the database, and you want to get them from there. Well, of course, you can create a model, put it in the database. You can delete it from the database. And most importantly, you can fetch these things from the database. And when you fetch them, you can fetch them in a certain order. You can fetch only some of them, etc. So that's really the power of this whole mechanism. And what's amazing about SwiftData is inserting and deleting from the database. It's just so simple. You really just create your models like you would even if there wasn't SwiftData, and then you just insert them and delete them from the database. And fetching a little more complicated. We'll talk about that in a moment here. But to do inserts and deletes and fetching, you kind of need a handle on the database. You need something to talk to say, I want to insert something in the database, or I want to delete something in the database. And that something, that handle is called a ModelContext. All right? And in any view that you want to access your SwiftData database, you can just use @sign environment, modelContext, var modelContext, and you'll have this var. And this var that you get from that, it has API to add and delete and fetch objects, and it also can control things in the database like whether you've got autosave turned on. You can explicitly save with it. You can do undo, because it has a really cool undo feature where you make a bunch of changes and then you say, nah, undo that set of transactions. It can do that for you. So all of this stuff is done through modelContext right here. But this environment variable is only going to work for views that have a ModelContainer set on them. And the ModelContainer is also an environment-like thing. You don't access it with @sign environment. You access its context with the @sign environment. But this ModelContainer, it controls all the stuff about where this thing is stored on disk. Is it a SQL database, or is it some other kind of storage mechanism, which it can be. We rarely have it be that, but it can be. Is it on disk even? Maybe it's in memory only. So this container is controlling all that information. It also controls things like schema migration. What happens if you ship your app out to 1 million customers, and then your 2.0 one, you want to change the vars on your @sign model in some way that's kind of incompatible? Well, you have to migrate the schema from the 1.0 customers to the 2.0. You manage a lot of that with the ModelContainer. Now, this ModelContainer, we almost always just put it as a view modifier on the top-level view in our @sign main. We'll say ModelContainer for whatever our @sign models are. And then it applies to all our views that ever appear in our app. So it's usually really simple to do it. It's a little trickier doing it with previews because, of course, we're going to have a lot of views that are using SwiftData that are previewing. And the thing about a preview is every time you change the code, it starts up again. It's like your app just keeps starting up again. So you really wouldn't want it writing to some disk somewhere and actually doing the SQL storage, but you still want it to behave like that. So we'll have to do a little bit of magic with our previews to make it work. But in either case, we need this ModelContainer for all the views that we're going to show. Also notice there, I've only said ModelContainer for codebreaker.self. I might have other models, like my code might be one, but as long as I can reach them with a relationship, I don't have to list them all. I can just list one of them, like codebreaker. I can reach all the rest of them, don't have to list it. So we'll see that ModelContainer right at the end of this lecture or right at the start of the next one. Once I have this handle, this ModelContext that I got with that @sign environment, how do I add things to the database? I just say insert. See, I've created my codebreaker absolutely normally there, name, test, peg choices, whatever, and I'm just saying insert it. And that's going to put it in the database. And I can delete it the same way, just say delete, it deletes it. Totally simple. And then there's fetching. A little more complicated, and so we're going to have to talk a little bit how to do fetching. The function is easy fetch, but the argument fetch descriptor there is a little more complicated because we have to say what we're fetching. Do you have a question? So the question is, are these asynchronous? And the answer is no, they are not. Okay? These are synchronous operations. Now the interesting thing is you can have your SwiftData store to iCloud, okay, so that you can see your SwiftData on all your devices. That asynchrony is happening in the background. So you are writing to your local one, and in the background, it's cranking it up to iCloud. Okay? And that's really nice they do it that way, because dealing with asynchronous code, I'm going to be talking about that next week, and it's a bit of a pain to have to deal with that and to you thinking that way. So this way you don't have to think about it. It's not asynchronous. All right. So let's talk about this fetch, and to really understand fetch, we have to understand this fetch descriptor thing, this argument to fetch, because it defines how we're going to fetch. And that's all that fetch descriptor is. And if you look at a fetch descriptor, here's an example one down here. There's really three things about it. One is which kind of @ model am I searching for? Like, am I looking for code breakers, games, or am I looking for codes? I might be searching for codes directly. There's no search that gives you back some code breakers and some codes. Now, it might give you back code breakers, and of course, if you access the vars of that code breaker, you've got codes, but you're never going to get a list that's mixed code breakers and codes. So this fetch descriptor defines that via its don't care. You see how fetch descriptor there has a don't care, angle brackets, in this case code breaker. That means this fetch descriptor only fetches code breakers. Then the second thing is, which code breakers do you want? And that's this predicate right here, the second line, that little hashtag predicate right there. And it just gets a little closure, and it's going to execute that closure for every single thing in the code breaker table in the database. And the ones that return true, it's going to fetch those ones. If it returns false, it doesn't fetch those. So it's pretty incredible when you think about it that you're specifying which ones you want with a closure, but it's going to be doing a SQL query. So it's going to turn that closure into possibly a very complicated SQL query on the database end to go get it. So there are restrictions on what you can put in that closure, and we're going to talk about that in the next slide. But let's talk about the third argument there, which is the sort by. And that's the order in which these are going to come back. So when we do our fetch with that modelContext.fetch, the result comes back to you as an array, and that array will be ordered. It'll be ordered by this sort by. Now this sort by is kind of crazy syntax here. Notice first that it's an array. See that it's an array? In fact, it's an array of sort descriptors, and sort descriptor also has a don't care, which is the same thing, code breakers. These are sort descriptors for code breaker models, and it's an array of them. So first, why is it an array? Well, if I'm searching for my employees, I'm probably sorting them by last name first and then first name last. So the array is just all the things I'm sorting on in order. And then the second thing is, what is this weird .init /.name? That, we have not seen that kind of syntax. Well, it turns out that you can initialize an object by essentially doing sort descriptor angle bracket code breaker .init with the arguments to the init. Now, we never do it that way. We don't say .init and put that like that. We don't have to do it. But the thing is, we could do it. And if we could do it, then we could use type inference to not have to type all the other stuff. You see? So that really is sort descriptor angle bracket code breaker .init /name, but type inferences make it so we don't have to type that sort descriptor code breaker. So this .init is just a way to type less things over and over and over. That's really all it's doing. We don't have to type code breaker so many times. We don't have to type sort descriptor so many times. That's all the .init is right there. So that's the sorting part of it. So let's go back and talk about this predicate thing more. This is what a typical predicate looks like. The predicate also has a don't care. We didn't have to specify it on the previous time because it was inferred. Type inference got it for us. But here I have a standalone predicate for code breakers. And inside there you can see that the closure just takes one argument, which is a code breaker. That game in is a code breaker being handed to it. And I can then execute some code. Now, because this code in there is going to get converted into a SQL query, it has limitations. So let's talk about what you can do in that closure. You can do math. You can add and subtract. You can do comparison. Less than, equals, not equals to. You can do all that. You can do ifs and ternary operators and or. Makes sense. You can do those things. Now, interestingly, you can do sequence operations. So if you're querying on something that's an array, for example, you can use things like all satisfy on it, or contains, to try and file into all the things in this array that you're querying that contains something. You can do max and min if you're querying on something maybe that's an array of numbers. You can also do subscripting, square bracket, some index or whatever, and really importantly, dot notation. Now, why is dot notation so important? Because a lot of times you're going to have vars in your models whose value is another model in a different table. And then that one might have another model. And you can actually use dot notation to follow them from table to table. And you can travel along these things as far as you want. So this dot notation, you can do this dot that, dot this dot that 5 times if you want to go and find something that you're trying to compare against or do an if on or something like that. You can also do string comparisons. One thing I'll say about string comparisons, very case sensitive, so be really careful here if you're doing string comparisons, searching for things by string. There are some things like case insensitive compare that you can do on a field in your database to get around that, but be careful with case sensitivity and string comparisons. And lastly, let's talk about the closure aspect of this. We know what closures do, right? They capture all the variables from their scope, and you can use them inside. And that's true here, except for only lets. You can't capture vars in there and then try to modify them or whatever. So just to simplify it, only lets. So if you want to make some lets before you do this line of code right here and then use the lets inside, no problem, you can do that, but not vars. So now you know how to make a fetch descriptor out of a predicate and a sort by that goes with a particular kind of model, which is the don't care of the fetch descriptor. So you create that fetch descriptor and then you call modelContext with it, and it's going to return you an array of all of the assigned models that match that predicate and in that sort order. Couldn't be simpler, right? Well, it could be, but it's not quite that simple because this operation can fail. And this is the first time in this class we've called something that can fail like this. And why can this fail? Maybe your database is corrupted, or maybe there's some other file system error or something that causes this to fail. Or, maybe your predicate has got a bug in it. You don't follow the rules in the predicate, and you're trying to access some var that's computed var or something, which is not allowed in your predicate. I should say that, by the way, yes. Your predicate, all the vars used in there, can't be computed vars. That whole closure is being converted to a SQL query, so it's happening on the database side. So it doesn't see any of your computed vars. There's no computed vars on the database side, just SQL commands. So now we're going to have to take a time out and talk about how we handle errors in Swift. In all of Swift, how do we handle errors? And the answer is that we mark any function that can throw an error. We call it throwing an error with the word throws. So if you look in the documentation and you see a func in there, and at the end of it, it says throws, that means it can throw an error at you. And every function that throws has to be called with the word try in front of it. See that blue try? See how that line of code with the blue try is exactly the same as the one at the top, it's just with try put in there? So I have to say try. Why? Because I'm trying this function call, but it might fail. So try is a really good word for this. And if you have something that has try in there, you have to put a do catch around it. That's the red. You see the red do catch right there? So the do catch has two parts. It has the first curly brace part, which is got a bunch of things in there that might try. And it can be multiple of them. You can do 10 things in there, all that are trying things. And then the second curly brace part there is where if one of them fails, it'll immediately jump down to that code, abandoning all the rest of the code up in the top part, and start executing here with that purple error, you see the let error, equal to the error it threw. And that error that it throws is totally dependent on what threw the error and what kind of thing it is. It might be a network error, it might be a database integrity error or something. And you have to know all the things you're trying in the do and what things they might throw. And then you can look at the error they threw, and then you can check it out. And maybe you can recover from the error. Certain errors you can recover from, certain not. Maybe you're reporting the error to the user at that point. And that's what's happening down there in the catch. Now, this let error that I have there, a lot of times we just leave that off because that's the default, let error. In other words, if you just say do catch, no let error, curly brace, then down in there, there will be a var called error, which is the error that were thrown, even though I didn't say let error. And I could also say let foo, and then it would be called foo in there instead of error. But usually we just leave it off and we call that thing error. So a couple things to note about this is notice that after I do the try modelContext.fetch, what do I do on the very next line inside the do? I start using the result. I print them out, doing other things with results. So I stay inside the do as long as my tries don't fail. I don't do it inside the do and then after my do catch is over, keep going. In fact, after this do catch is over, that let results is not even defined because that let results is inside the do. It only works inside the do. So this is how you do it. Do catch, do all your stuff in there, and the catch, you catch the error at the end. And that's true for all error throwing and catching. And certain parts of Swift have more throwing of errors than others. Like if it's involved with the network, lots of throwing. Things throw a lot on the network. If it's involved with the file system, more throwing things on the file system. And obviously with the database, you get things throwing. Yeah.
If you know the types of errors that you're looking for, can you add more catch statements to catch specific types of errors? Kind of like a switch case?
Yeah. So the question is, can I kind of have a switch statement and catch multiple different kinds of errors? And the answer is absolutely. You see where it says catch let error? You can actually have a catch where the error is of this type, and then another catch where the error is this type. So you can have multiple of those catches. You just go curly brace, catch error is whatever type, catch error is another type, catch error is another, or even catch error is a kind of error in here. Catch error is a specific type. You see what I mean? So you can have it with multiple catches. Of course, you could also have one catch and inside there have a big switch statement over your error codes or whatever. So you kind of do whichever way you want to do there. It's a little more advanced do catch. Here we're just introducing the idea. As I said, the rules here are that any function that throws, that's marked with throws, has to have a try. You simply cannot call it. The compiler will not let you call it. The interesting thing here is that if you have a try, you have to have a do catch around it, except for there's one exception to that, which is if you're in a function that throws. You're inside a function that has throws marked on it, then it can not do catch. And if this thing throws, then your function will immediately throw that error out. The throws will just immediately start flying up the call chain of things that throw. But this is a little bit onerous to have to put do catch around every single thing that might throw. So we've got a little bit of help, which is there are two other versions of try. One of them is try exclamation point, and the other one is try question mark. You don't have to put these two inside of a do catch. Try exclamation point means try this, and if it fails, crash my program. So this feels a lot like you have an optional and it's nil and you exclamation point and it crashes. Same kind of thing. You're just going to immediately crash. Again, you might use try exclamation point during development if it's things where you just think this should never crash, and if it does, I want to be right in the debugger where it crashed. And then there's try question mark. Now, try question mark is fascinating. We actually use this one quite a bit. What this does, it tries the thing, and if it fails, it returns nil from whatever function you're trying to call. If we use that for our modelContext fetch right here, that return value results, it's not an array of code breakers anymore, it's an optional array of code breakers. Because that try question mark might fail, in which case it would return nil. And this is a great way to call something that throws, and you can't do anything about what kind of error it is. You might be able to do something if it throws an error, but a particular kind of error, you have no idea what to do about it, or you just don't want to deal with it. And all you want to know is whether it failed. And you'll know whether it failed because it will return nil. So that's all there is to error handling, really. It's pretty straightforward, and it's a really nice system, actually. Now, this way of fetching with ModelContext and doing fetch, it's great, works great, got these fetch descriptors, but actually we almost never use it. Okay, we almost never call ModelContext.fetch. That's because we have this fantastic little macro here called @query. We use it in the same kind of place we would use @state or @binding, right? We just put it on a var. And what @query basically does is lets us define a little array of things and have that array of things always be filled up with the results of a query. And that query is basically just a fetch descriptor. Its arguments you can see here, @query. It has a predicate and a sort by, almost the same as a fetch descriptor, not exactly the same, but very, very similar. And it's just essentially just going to always do that fetch at all times and keep that var games code breaker, you see it up there, filled up with the right code breakers. So this looks like 2 lines of code. It's really one big line of code. My slides can go nowhere near that wide. But you can see that this is going to have games right there, is an array of code breaker, and it's always going to contain all the code breakers whose names contain foo. var games will always have that in there, no matter what happens. If you have other code that's inserting code breakers, deleting code breakers, this is just always going to update and always be exactly a match for what's in the database. And it's going to auto-update your SwiftUI. Just like an @state changing or an @binding changing, well, @query, if this changes, if that array changes, boom, it will do it. Now, do notice that the arguments are slightly different. The filter in fetch descriptor, that's like the predicate argument. And then the sort is kind of like sort by in a fetch descriptor, except for here, you just put the var names. You don't have to put the .init, parentheses, .name, sort descriptors thing. You just put the var names. And it also has an order, forward order or backwards order. So that array is going to be in that sort order. It's going to match that predicate, and it's always going to be in that state. It's very efficient and quite a simple and amazing way to do it. And you can see with this, why would we ever do model context fetch? Well, I'll show you in the demo why we might do it, but it's pretty rare to do it. Now, that @ query, it had a fixed predicate and a fixed sort by, right? It was always sorting by name, and it was always looking for things with foo. Well, what if you wanted that to be controlled by variables? Like, what if instead of foo, you wanted something that the user typed in? Like, the user wants to search their games. They want to type in the name like Mastermind and have it search for Mastermind. Or what if you want the sorting to not be by name, maybe you want it to be by most recently played game? Well, you can't do any of those variables in that @ query thing. That @ query thing, everything has to be fixed, what's in there. So if you want to drive an @ query with variables, you have to do it by constructing the @ query in the init of a view. And this seems like a massive restriction, but it's actually not that bad because, of course, we know how to decompose views into helicopter views. And so we just decompose our views such that when we're getting to do the query thing, we just create a view and pass it some arguments like the search string and all that stuff. And inside that init, we'll make the query that we want. And this is a lot better seen in demo. Okay, so I'll be doing that in the demo on Wednesday, and you'll see exactly how we do this. But that is how you make the arguments to a query be variable instead of fixed. All right, that's all I wanted to talk about with SwiftData. So now we're going to dive into this demo. And today, again, all we're going to do is convert our codebreaker model to use @ models. And it's going to require us to massage our data a little bit because not all of our vars in our model are the right kinds, right? They're not all primitive data types or whatever, so we're going to have to fix some of them. All right, so let's dive in and do that. Normally in lecture, I make a little change to a code and we see it in the preview. And so you're kind of seeing what I'm doing as we go. Well, here, I'm not doing any UI stuff. I'm just doing the model side of it. So I'm going to just close this thing because we're not actually even going to see this thing again, this preview, until the next lecture. Once we get our model converted over, then we start inserting and removing things, then we can start seeing it. So, what do we do to convert our model? Well, we are going to go immediately to our model. And I'm going to do the thing you almost always do first, which is you change your @observable class to be @model. Now, of course, to do anything with SwiftData, I need to import SwiftData. Anytime I'm declaring a model like this, or if I'm using that modelContext @environment thing and I'm calling insert and delete or fetch or something like that, I always need to import SwiftData. That's in a different package. It's not in the SwiftUI package. Yeah?
Does that mean we need to change data from class to binding?
Yeah, so the question is, when I change this to an @model, do I have to change stuff in my UI, like from @bindings or lets? Well, if this was a struct and I change it to an @model class, then I might have to, because I might be passing something by binding I don't need to anymore, because then now I've made it a class. But in this case, no, because it was already a class, an observable class, and I just switched it to model. Now, we are going to make our code be a model, and then we are going to have that problem. We'll see what we have to do. Yeah?
What if you use SwiftData and model versus code?
So the question is, when would you use SwiftData versus some third-party data storage mechanism or something like that? Same answer anytime you would say, when would I just use something built in versus something that is from a third party? And it totally depends on your requirements. Maybe if you're doing a cross-platform thing or something, there's no SwiftData on Android, for example, so maybe you would want to use a cross-platform thing. Or maybe there's some feature set of some third-party thing that matches what you want to do. But if you want to do pretty simple and straightforward database storage, you're going to see SwiftData is really simple and straightforward. So it's good for that. It is iOS only, but it's simple and straightforward. You see what I mean? It's just one of your tools in your tool chest. So we got this @ model here. We need to go through our vars and make sure they all match those requirements I said. They each have to be a primitive type or an @ model, whatever. So let's look here. Var name. Primitive type, no problem. Nothing to do here. These three, the type is code or array of code. This is a problem because code is a struct, and it's not an @ model, it's not codable, it's not a primitive type, it's nothing. So this is a problem we're going to have to fix code, and like I hinted at, I'm going to fix it by making it an @ model. But let's look at the rest of these. How about peg choices? This is an array of peg. What is peg? It's a color. Big problem. Color is not a primitive type by any means. So again, we would have to make the color codable or make it an at-sign model, which we can't do because we don't have control of the color class. We could make it codable because we could use an extension to make it codable if we wanted to. But we're not going to do any of that. I'm going to finally catch up to you guys and make my peg be a string. Because string is a primitive type, and there's going to be a lot of advantages to make it a string. But we'll get to that eventually. And then what about these three guys? Start time, end time, elapsed time. We got date, no problem, that's a primitive type. Time interval is a type alias to double. It's a double number of seconds. That's what a time interval is. So that's no problem. Numbers are primitive types. So all we really have to do to make this work is this code one and fixing our color. So let's start with fixing code. And I'm going to fix code by going over to code, and I'm going to make this be its own at-sign model. That means there will be a table in the database that's all codes. And I've already got one table that's all code breaker games. This is going to be all codes. And I just do this by saying at-sign model class. Now, I've just changed this from being a struct to being a class. So that's something to consider here. And of course, I need to import SwiftData because anytime I'm doing this at-sign model stuff, I need to do that. Now, we already saw switching something from a struct to a class before. Remember, we switched codebreaker from being a struct most of the quarter, and then I said, oh, no, I'm going to make an at-sign observable, and that meant I had to make it into a class. So we already know some things that happen, like we already know mutating makes no sense on a class because all funcs in a class are mutating. We have references to them. They're in the heap. We can change them all we want. So we always get rid of these mutatings. So randomize and reset, obviously. Don't need mutating. That's all we have. Those are the only two mutating functions we have is randomize and reset in code. Now also, look here. It's saying at-sign model requires an initializer be provided for code. So this is really two things going on here. Just because code is a class, it needs an initializer. And this is a good chance for me to remind you of difference between structs and classes. With struct, remember you get a free initializer. It initializes all the vars. So you get a init with a whole bunch of arguments that lets you initialize any and all of the vars that you want. That's the free one you get in struct. In class, you get a very different free init. It has no arguments. It's kind of the exact opposite free init. So free one only works if all of these vars have an equals something that initializes them. Because if you call init with no arguments, somehow those things have to get initialized. So we have to have an init here just because it's a class. It also sounds to me from this error message that at-sign model is requiring you to have an init, probably independently of that. Not sure why that is, but I'm listening to what it says. But in any case, we need an init, so I'm going to use escape completion here and get the init that our little AI code completion does. And this is a perfectly fine init right here. You see it just takes the kind and the pegs for this thing, and it assigns them to these variables. The only thing here is, because this is the only way to initialize this code now, there's no way for me to get this default. Yes, when I try and create the code, it starts out like that, but then I immediately use whatever they passed me and overwrite that. So I've lost this, but I can get it back really easily by just taking it and making it be the default argument to this init. Now, if someone doesn't provide pegs, then they get these nice 4 missing pegs over here. One other thing that's a little bit hidden here that broke when we changed this into a class. What's another big difference between classes and structs? Structs have value semantics. Classes have reference semantics. And if you'll remember, we actually wrote some code back in Codebreaker view, an attempt guess down here, that took advantage of value semantics. Remember this? I did this intentionally so you would see how you could take advantage of value semantics. But now we've actually broken that because our code is no longer a struct. It no longer has value semantics. So this code is really bad. This code, var attempt equals guess, that does not copy the guessed into an attempt. It just has 2 pointers to the same thing. And then on the very next line, it resets its kind to be attempt. That sets both the guess's kind to be attempt and the attempts. Wow, that is horrendous because the guess wants to stay kind.guess. So this is a really bad bug. Notice the compiler can't catch it, doesn't know anything about it. It's a good thing I caught it, because we would be trying to figure out what is going on with this thing. It's just not working. So luckily, we're in good shape here. So I'm going to fix this. I have to actually make a copy of the guess. This attempt that I'm making has to be a copy of the guess. So I'm going to do that by saying let attempt equals. I actually copied my code breaker in the last lecture. Remember that? We copied it so that we could put it up in the little sheet that came up, and then when we hit cancel, it wouldn't do it. The way I did that is I created a new one, and I'm going to do the same thing here. I'm just going to create a new code. I have to give the kind, which is that attempt thing, and then the pegs are the guesses pegs. I think that's fixed all of the problems that got introduced by switching our code from being a struct to being a class. But there's one cool thing while we're in here. You see this little extension we did to Codebreaker? We did that so that Codebreaker games would be identifiable. That made it nice for our for eaches that we did. And hashable and equatable, so we could do things like navigation link, value, game. It was really great to do these three things. Well, guess what? Model gets those for free. So you do not need any of that for a model. And model is always equatable, always hashable, always identifiable. Kind of a nice feature of those. Let's go back here. We fixed this code stuff here by making that an @sign model. These are all perfectly valid now since code is an @sign model. But I am going to go here and put some of these schema attributes on here. Specifically, these are all relationships. There's a relationship between a Codebreaker game and these codes, those two tables. And I'm going to enhance this relationship by making it so that when I delete this game, it deletes those things from the table, like I talk about in the slides. And I do that with this @sign relationship thing. And inside @sign relationship, look at the help it's giving there. There's the delete rule. There's that inverse thing I talked about. And so I'm just going to do delete rule here. Dot cascade, which means cascade the delete into this other table. I'm going to do that for all three of my kinds of codes. And notice that the cascade will go through an array, because my attempts is an array of codes. So it'll actually go and delete all the codes in that array, in that other table. And there's, again, this is where you would put inverse if you had that two-way pointer, if you had a back pointer or something like that. Another one that we could put here actually is on start time. I'm going to mark it transient, just because I think it makes no sense to store the start time in the database. Think about that. The thing appears on screen, the start time starts going, then it saves it in the database. You go use another app, you come back 3 days later, it unloads it from the database again, and now you're starting from 3 days ago. No, the start time gets started and stopped on disappear and on appear. It shouldn't be stored in the database, so I make it @sign transient. Now, one thing I'm going to warn you about @sign transient that I've noticed, I looked in the documentation, I couldn't see a definitive statement on this, but it appears to me that @sign transient vars don't update the UI. So if I change start time, I don't think my SwiftUI bodies get rebuilt like all the other vars do. So I don't know if that's really true, or whether that's the way the semantic's supposed to be, or whether it's a bug or what, but it doesn't. So that means anytime I change start time, I'm going to have to tweak some other var to cause my UI to change. Like maybe I'll tweak my elapsed time, add 1,000th of a second or something to it. That'll cause the UI to update. It's kind of weird. We've taken care of these code vars in here, but actually back over in code, we never did the thing where we looked at all its vars to see if they are okay. And in fact, let's look at the very first one. What is kind? It's an enum. This definitely can't be put in the database like that. So how are we going to deal with that? Well, let's look at a couple of options. One is, what if I made kind codable? And I just dropped the kind into the database as a little data blob. And let's try and do that. So I'm going to say here that this is codable. Now, a lot of times when we do this, say codable or hashable, we cross our fingers and hope that Swift can synthesize conformance for us, right? Come up with the functions necessary, especially with codable, because we don't know how to do codable, and it's not that easy. It's not that hard, but it's not that easy either. But unfortunately, it doesn't work. Why is it not working? We click on it. It's saying that code.kind does not conform to decodable or encodable. And in fact, the codable protocol really is just decodable and encodable, those two protocols. It says cannot automatically synthesize it because, array of match does not conform to decodable. So if you have an enum, it normally would be able to synthesize it, but it can't because we have some associated data, and this one is an array of non-codable things, so it doesn't know how to code them. No problem. It's easy. Let's just go make match be codable, and then that should make kind codable, right? Because we know bool is going to be codable. That's a basic type. So where is match? Where did we put match? Okay, match is still in the UI, because when we put match in, we didn't even have a model. This was like in lecture 1 or lecture 2 or something. So this really does not belong here. So let's get rid of this out of here and go put it in our model. Put it at the bottom of code maybe or something like that. And likely I should be putting match inside code, just like kind is, but I don't want to change all my other code. But if I was going through the process like I'm going to ask you to do in A5 in the challenge mode, which is clean up your code from the quarter, I would definitely put match inside of code here, because match only makes sense for code. So I will want to namespace it there, but I'm not going to do it today. So I want to make match codable, and let's see if that just fixes everything. Ready? Here we go. Match codable. All right, let's go back up and see. Kind? Yes, synthesized. So this would actually work, just like this. This would make this kind be able to be put in the database, no problem. That's all we would have to do. But I'm not going to do it this way. I'm going to do it another way. I'm going to represent my kind as a primitive type, namely a string. Now, why would I make it a string versus just doing this really easy codable thing? Well, what if I wanted to search by kind? What if I wanted to find all the games that had attempts where all the pegs were inexact, where I guessed them all, but they're all in the wrong place? Well, I have to go look into the kind and look at the matches in there. I can't do that if it's a codable blob. All I can do is equals basically on that. So that's no good. So what if I made it a string, and then I made the string representation of a kind, have the word guess in there, and attempt, and master, and then for the match, the associated data, it had inexact and exact. You see what I'm saying? If I had that as a string representation of it, then I could query. I could do string queries in there. That's not quite going so far as to make kind a model, which that would be difficult, because kind is an enum. And making it a model means I have to make it a class. That takes away all the niceness of it being an enum. I'd lose all of that. So I don't want to go all the way and make it a model, but I still want to be kind of queryable. So by making it a string, I can query. The thing is, how would we do that? So I'm going to take this codable off. So we're not going to make kind be codable. And instead, I'm going to go up here, and I'm going to change kind. Instead of being a kind, it's going to be a string. Now, the problem here is I got a whole lot of other code that thinks that's a kind. And it's looking at, is it equal to no match? Is it equal to exact? Whatever, all that is broken by doing this. So we don't want to do this. And this is where that computed property thing comes in that I talked about. How about if I make this be underbar kind, and then I have a var kind that's still a kind, and it has a get and a set. It's a computed property with get and set. Everyone hopefully is comfortable with the idea that computer properties are both get and set. Read that in your reading assignments, I hope. And then this get and set will just get and set this thing. And if I do that, all my other code's going to work, because all my other code will now start using this computed property. And I only have to deal with the fact that it's a string in these two little pieces of code right here. So that's really, really nice and efficient. So now the question is, how do I convert a kind to a string and back? And for that, we're going to use AI. Now, I don't know how many of you did the challenge mode in assignment 2 where I asked you to go do AI to do a color to and from a string. For you, it might be old hat, but for others of you who didn't do that challenge mode or whatever, let's just go try it. Now, this is where, when you're doing a live demo, you're like, oh, I hope this goes right, because you just never know what these AI guys are going to give you. But let's give it a try. Let's go over here. Let's bring up our browser. I'll use ChatGPT because I don't have to log in or anything for that, so chatgpt.com. Here it is. What can I help with? It says log in. I'm not going to log in. Stay logged out. And essentially, I'm going to give it that kind enum and ask it to make it convertible. So let me go grab that kind enum first. Here it is. And it'll need match as well. So actually, let's do this. Let's take match. Oh, match. This is interesting. I can have match convert to a string by just saying match : string. Have you guys seen this from your reading? You know what this does? If you say match : string, it makes it so you get a var raw value of type string that is on your match, and you can ask for it, and it will be this, in quotes, no match, and you can even set it to be something else by saying equals none, and this could even be an int, in which you could say 2. It would be 0, 1, 2 by default. This little thing of making a enum into a string is awesome. It also gives you a failable init that takes a raw value, and gives you back a match, as long as the raw value string that you give it is one of these 3 things. So that's awesome, right? So in fact, let's do that for match, and then let's see if we can do it for kind as well. Let's go up here, kind, string. We might not even need ChatGPT, right? Doing that colon string thing doesn't work if you have associated data. And you can see why. Like, well, how would it really do that? It would have to be overly complex to do that. So, darn it, we can't do it. But we can do it with match, so let's just leave it with match. And so I'm going to copy this thing and give it to ChatGPT, but let me just take match and put it inside it, just so I can copy and paste it so that ChatGPT knows what it is. I'm not putting it there permanently, just going here so I can go copy, and then I'm actually getting rid of this match thing. So I'm just copied it because I want to give it to ChatGPT and ask it to do this string thing. So I'm going to say enhance this enum to make it convertible to and from a string, colon, paste. There it is. You see there's my enum kind. It's got the match in there nicely. Let's see what it comes up with. This is really cross your fingers here. You just never know what these things will do. But let's see what's it doing here. Oh my gosh, look at that. It's doing Codable. Put Codable in there. Ooh, coding keys. Oh my gosh. Okay. We don't want to use Codable. We're trying to avoid that. So let's just say don't use Codable. Let's see what it comes up with here. Ooh, this is looking good. Look, see, the description is a string version of it. It's got master is hidden in there. Here's my matches joined by a separator comma. Okay, that sounds good. And here's the other way around from string. Although this is a static func, I'd really like this to be a failable initializer, or even actually a non-failable initializer, because we have unknown. We have the kind unknown. So let's just return that. So I'm going to say make the from function be a non-failable initializer. Non-bailable, what that means. Okay. See what it comes up with here. Okay, we've got description, that's good. Oh, there it is, init with a string. Look good, yeah, Yeah, I don't know if this is going to work, actually. We'll see. This code doesn't look very good to me. What do I know? I'm not artificially intelligent, but let's find out. So I'm going to go over here and go create a new file for this. See, look, create kind.swift from clipboard, because I copied that whole thing. Let's do it. Here it is. Here's kind. We don't put match inside here, so let's get out of here. And then let's build and see how it did. And, it actually compiled. Whether it works or not, we'll have to see. When you go to ChatGPT or any of these AIs, sometimes it'll work and sometimes not, but let's hope. And on Wednesday, after we finish this conversion, we'll start running our app. And if we don't have good kinds, then we'll know that this is a problem. So let's go back to code here. We can get rid of the enum kind that's in here, because we're going to use the one from the other place over there. And now we just need to do the get and set of this using the functions that we just got from ChatGPT. Get is somebody asking for the kind. So in that case, we need to take this string and create a kind from it. So I'm going to say return, call that failable initializer with underbar kind as the argument. See if that compiles. It did. That makes sense, right? We added a non-failable initializer over here. Here it is. Takes a string. Seems to possibly do the right thing. Let's hope. And then what about on the set side? This is someone saying kind equals .guessed, kind equals master code hidden, or whatever. Here we need to set our underbar kind equal to that new value they set it to, .description. So description over here was this thing it created up here that creates a string description of this. We cool with that? Did that compile? Yes, it did. So maybe we're good here, maybe we're not. Anytime we import code like that, we just won't know until we get going out there to see what's happening. My original prompt, let's go back and look at it. Up here, I said, enhance this enum to make it convertible to and from a string, and then I just copied and pasted it, and I had put match in there temporarily so it would have it all in one go, and so I didn't have to do both things. When I'm doing a lot of this model stuff, I'm kind of changing my vars out from underneath it, and the model thing is generating a lot of code and stuff, so sometimes I like to do clean build, and then do Command B to build it, just to make sure I'm getting all the latest stuff. So when I do a build, I am seeing these errors over here. Look, referencing instance method set value, referencing instance method get value. It's like, where are these? I'm not calling get value or set value here. Where the heck are these? Well, if you click on them, bloop, it shows this gray area. This is the code being generated by @model. I told you that @model is a macro. It processes your code, turns all your vars into computed vars, basically, and does all this stuff in here. I don't even know what all this stuff is, and I don't want to know, but I do know there's an error in there. And when you see this kind of error, referencing instance method on array requires that this peg, aka color, conform to persistent model, means I can't persist a color. A color is not a primitive type. It doesn't fall under the list. So we have to fix this pegs right here so that this is either not color, or we have to make color codable or something so that it'll work. And you can always close these gray boxes with that little X that comes up there. Now, I told you how I'm going to fix this peg, which is I'm going to make it a string. Let me talk a little bit about why I decided that making this a string is the right way to go. And I really talked about this in your assignment. By making this a string, I've just made my model way more powerful. Because now this model, once I fix all the problems that come up from making it a string, it could be an emoji codebreaker game, it can be a color, it could be words, it can be anything that can be represented as a string. That's a lot more powerful than a codebreaker that can only do colors. You see? So by just this one little change, I've made this more powerful. And I get to stop saying import SwiftUI core and say import foundation. So now I really have a true UI independent model. I have nothing about colors anywhere in my model. My model knows nothing about colors, and I'm going to keep it that way because I want to be able to build UIs for emojis and UIs for colors and UIs for words to my heart's content and not have my model get in the way. Changing this, though, to a string is going to break some things. For example, over in our code, we have this missing peg right here. That's currently clear, the color clear. I'm going to make that be empty string. By the way, in your apps in assignment 5, you might want it to be underbar or space, because I think you're going to have code's pegs right here not be stored as an array of pegs. I think you're going to store this as a string. Because in your app, your word-based code breaker, all of your codes are strings. They're 5-letter words or 4-letter words or 3-letter words or whatever. That's going to fix this problem with pegs, but it's also going to fix the array ordering issue, which we're going to have big time on Wednesday, because our pegs are going to be in all random order, because arrays are not ordered. But if you make it a string, you're in good shape. All the letters are in order. I do want to fix one other thing, which is this. Look at these errors. Self used in property access kind before all stored properties are initialized. In a class, before you call any computed vars or functions, you must initialize all your variables, all of them. And this is saying that I'm trying to call this kind, see, kind equals is calling this setter for this kind, trying to call this, and all my vars aren't initialized. And you might be saying, well, you're trying to initialize your kind right there. Yes, but this is the actual var. It's this underbar kind. So I'm trying to initialize it by calling a computed var. That's not allowed. So I need to make sure that this and this have values before I execute this line of code. So I'm going to do that by putting this line of code after this. That takes care of the pegs. That gets the pegs done. And I'm going to fix it by having this be kind.unknown.description. So I'm going to start my underbar kind as just unknown. And then, of course, this is going to immediately change it to the right thing. So back to our problem of we changed this peg to a string. And what's breaking? Well, what's the number one thing that's going to break when we change peg to a string? And that's that our peg view is not going to work. Because our peg view does foreground style peg. It expects peg to be a color, and that needs to be, obviously, a color converted from this string somehow. So we're going to go back to ChatGPT and have it do colors to strings. Go back over here and write an extension to color that converts it to and from a string. And actually, let's just make sure it knows that I'm talking about SwiftUI color. Let's see what it comes up with here. Okay, it says that it's going to do a hex representation over here. That sounds okay to me. A 2 hex string. Okay, I'll buy that. Although that's optional. I don't think I want that optional. Actually, maybe we'll just do that in the code to make this quicker. So I'm going to copy this, go over here, and go create a new file for this. So this is a Swift file. Usually when we make an extension to something, we give the name of the thing we're extending and say plus, and then a description of what we're doing. So in this case, we're adding string support to color in an extension. So color plus string would be a really good name for that. This is part of my UI, not part of my model, because color is a UI thing. So click, here it is. Let's go ahead and paste. Build, let's see. This actually worked. Woohoo! The only thing here is I do not want this 2 hex string to be optional right here. And this is because of this right here. So let's just not do this guard. I think we can get away with that. And the reason I don't want that to be optional is I just don't want to have to constantly deal with, converting this thing to a hex string. It's an optional, what's it going to be, etc. I'm the one putting these things in the database. And I'm also just going to call this var hex to make it a little simpler, because this one's called init hex up here. So build. Does that work? Yes, it works. Woohoo! Okay, we made it. Now we can go back to peg view and fix this. We got this foreground style peg. We're just going to make a color out of that peg by taking this hex version of the peg. And if that comes back nil, we can't convert from that string, then I'm going to make this be a clear peg. And then back down here, I'm just passing blue in my preview, so I'll just say the hexed value of that blue right there. So that's it. I fixed my peg view. So what other problems do we got? Let's see here. Let's go ahead and build. Okay, we got a problem with peg chooser. Look at peg chooser over here. So peg chooser, it's really just its preview that's got a problem. It's trying to pass choices in here. These are pegs. That means they're strings, and I'm trying to pass colors. How about if I just take those colors and map them to strings? Dot map, and watch this, / hex. That's a cool version of map where you just give it the var to call on each of them, and it'll map it to that. So that's the same as saying open curly brace $0.hex. So that fixed that. What else we got? Oh, we got a bunch of them here. Game editor. Game editor is trying to create a code breaker. That's interesting. Game summary. Oh, it's also trying to create a code breaker. Yikes. Everybody, I think our code breaker views preview. Yeah, it also trying to create. All right, anybody who tries to create a code breaker is having a problem here because they're trying to create it with colors. Now, I could go to each of these guys and fix it by doing .map hex, .map hex, .map hex. But I call this at least 5 times where I'm creating things. So what if I just add an initializer to CodeBreaker that takes colors? You see? And then have that initializer convert them to hex. That would be cool. But if I do that, I'm not going to put that code here in my CodeBreaker alongside this init, because that would mean I'd have to put color here, and then, oh no, now my model's not UI independent anymore. So I'm going to add another init in my UI by using an extension. And this is what I was saying before, where you can use extensions to add things to your model that are UI things. It doesn't change the fact that your model is still completely UI independent, because you're extending it inside your UI. Now, while I'm here, by the way, I see that it's not liking this at all either. This is the default value for the pegs. Happens to be the mastermind pegs. I got a good fix for that. Let's just get rid of that and force anyone who creates a code breaker to give me the peg colors. Especially since our peg is now a string, why would I force the mastermind colors as a default? That makes no sense. I could just as easily say they should be emojis as a default. All right, so let's go back to CodeBreaker view over here. This is probably a good place to put this extension. I'm going to make an extension to my model, CodeBreaker, and it's going to be an init. Now, it's an init on a class. And when you add a convenience initializer like this to a class, you have to actually say convenience init. Can't just say init, you have to say convenience init. Now in a struct, you never do convenience, but in a class you have to. And if you did your last reading, which I de-emphasized, so maybe you didn't get to this, but it explains why this is. Classes have designated initializers. It has to do with inheritance and which inits get called by when a superclass is. So a convenience init is just a way of helping it understand all those dependencies between superclasses and all that. So we don't really care about that too much. And look at this beautiful little suggestion by the AI, which I will take, although I don't want to call this default player. Call it CodeBreaker as my default name of my game. But it seems to know that I want this to be a color, not a peg color, but a color. And this is the init I want to create. Self.init with that name and with those peg choices, but those peg choices are going to be mapped to .hex. Now that I've added this convenience initializer, all those other things are fixed. If I hit Command B right now, none of those other things like the game editor and the game summary, none of those are complaining. That way of fixing things by just adding a convenience init like that, way better way to do it. Because all that other code we wrote it that way for a reason. We wanted a color-based thing in our UI. So the fact that our model has gotten more expansive, if we can just add that little convenience init and still think of it as a color CodeBreaker, it's great for us. It's not just less work, it's actually semantically kind of more what we want. All right, this is the last place we have a problem, which is the peg choices chooser. This is the color picker, right, that's in the thing that comes up and lets us edit a game. And it's got a color picker there that actually binds into a color in our game. Oh, we are in trouble here. Because how can we bind a color picker to a string? Our peg choices are strings. They're an array of string. Well, again, we're going to do exactly the same thing. We're just going to extend our model on the UI side so that it has an array of peg colors. And then we'll bind into that. Because you can bind into computed properties just like you can bind into stored properties. So I'm going to go back to my CodeBreaker view again, same place where I added this little convenience init, and I'm going to add a convenience var peg color choices. And it's going to be a little get and set computed var. And in the get, I'm going to get my peg choices that I have, but I'm going to map them to be colors. Color, hex, $0. And if I can't map it, again, let's do clear. That seems to be our default missing peg color, so we'll do that. And then on the set, if someone sets my peg choices as a color, then I'm going to set my peg choices equal to the new value they gave me, but I'm going to have to map that to be the hex value of them. See how I'm using computed properties here to abstract away my model? So now that we have this peg color choices here, let's go over and look over here. We still have to fix our peg choices chooser to not use pegs, but to use colors. So this really, I almost want to rename this to color choices chooser, because it doesn't really choose pegs anymore. It chooses colors, and same things with its preview. So I fixed this by just making a color. But this, of course, is going to break the place that I use this peg choices chooser, which is right here in the game editor. Let's go look at that. Peg choices chooser. The peg choices are the game's peg choices. Game peg choices is an array of pegs, array of strings. But I just added a nice little var called peg color choices. Woo, that is an array of colors. And so I can bind into it. So binding like this does work when you bind through a computed var. It works just as well. Swift does not know the difference whether it's computed or not. Let's build. Oh my gosh, build succeeded. It's been so long since we saw build succeeded. Now, is this going to work? Not quite. There's one thing that's not going to work. If I tried to run this right now, it would crash all over the place. Why? Because we're doing a lot of SwiftData stuff here with assign model and setting vars and stuff, and we have no container. We have no SQL container. Remember I said we have that container? So let's go ahead and put the container on there. We'll get back to this and talk more about the container next time. But that's in our app, right? Here's our app. I'm going to say .modelContainer for code breakers. And yes, we could also say comma code.self. That is legal to say this, absolutely no problem, but not necessary because we can reach code via code breaker. And if we're going to do SwiftData in here, we better import SwiftData. So I'm going to run this once. We're out of time. I'm going to run it. Maybe all our colors won't work because our ChatGPT for colors is wrong. Maybe our kind is wrong. Well, let's just cross our fingers and see what we get. Oh my gosh, it actually worked. Okay, there's the colors are right. We go over here, and can we even play the game? Oh my gosh, this would be a miracle. Good job, ChatGPT. It is working. That is amazing. That works. So this is good. We're at a perfect stopping point right here. And next time what we're going to do is actually start putting, right now this is not putting this in the database. If I quit this and rerun, it would go right back to looking like this with 0 attempts here. It would not be saving anything because I'm never actually putting any of these code breakers in the database. I'm creating them, but I never save them. I never do that modelContext.insert, right? So we'll start doing that, and of course we'll start fetching them, and we'll start ordering this list and doing all kinds of crazy stuff. That's all the stuff we're going to do on Wednesday. So I'll see you guys then.